Hello and welcome again to Steve's Long Stay Workshop. And today on the bench I've got something which I don't think I can fix, but we'll try, we'll do our best. It's not a radio this, it's a power supply unit, a switchboard power supply, given to me by Andy at Vintage Electronics Repair. And he used to have it on his workstation at home for his amateur radio, but it died. This one, by the way, is a Maas MPS-330-ii. It's about 13 years old, and this is a switchboard power supply. Now, switchboard power supplies came into being because linear power supplies take up more room. But changing the DC that comes in, the AC that comes in to DC, and then chopping a transformer at high voltage means a smaller transformer can be used. There's also a startup voltage as well in these, and so from that, this little unit here carries about will carry up to about 30 amps. Although I'm not going to put anything like that through it here. It's adjustable, and when you get one of these in, the first thing to do is look around it and see what you can see. Any blackened areas? Well, in this case, no there aren't. The fuse in the back, by the way, in this, I'm told it's okay, but just one second. So, get a screwdriver, the right size, I think that'll do it. Yeah. Take the screws, fuse at the mains, and have a look. See if it's blown. In this case, actually, I'm told it's not. So obviously, we'll check and see. Okay. So this is the meter which I use for checking fuses with. It's simple power and simple continuity test like that. This goes a few loops alright, doesn't mean it is, by the way, so always check and make sure. Yeah, that one's fine. Now, if a fuse is blown or not, and the state of the fuse when it is blown can tell you where in the set the problem might be. This one, the fuse is okay. Had it blown, the question then would be, would it have blown through gently, just opened, or would it have been blown apart? You can't tell with sand for fuses, but with that fine you can, and that one's okay. If it's simply blown apart gently, put another one in and see what happens. If it's blown apart properly, I will look around the board very carefully, look at the bridge rectifier, the startup circuit, and the chip which tries to transform, that sort of thing, and make sure they're okay. Also, capacitors, of course, always a problem. Oh, well, because we know that with caps, didn't we? Caps are always a problem. Without fail, caps are always a problem. It goes without saying, doesn't it? Anyway, now, of course, next thing we do after that is look at the output, and on this one, it's a dead short, an absolute dead short, 0.03 ohms. That could be the lead. That is dead short. That output is dead short. If the output is dead short, we'll get anything out of it at all. If the output is dead short, also, that means that chances are this set's well, it makes a noise from inside. I don't know what, but nothing there that would not smoke or anything. Nothing apparently getting hot. So now we've got the 20 volt range of the meter and put it on. And guess what? Deader than a dead thing. Completely and utterly dead. Nothing compared to itself. The battery on the front, nothing. And there's 2 or 3 places where this thing can go, but there too. Basically, this thing is doing absolutely nothing. Diddly squat. Absolutely all. Right, okay. We know but it's got a dead short on the 8 put, so leave that in place, and I think we should go and look at that first. These have a diode on the 8 put side of the transformer, as well as all the stuff, so it could be anything here that's gone dead short. But I think this is not a transformer, I think it's something on the 8 put stage here. So at this stage what we do is start doing the old which do the hope for the best business, which is what we'll do. So power off. Interesting. Power off, and we'll take out a couple of parts and see what happens. The cap here, you see, which I'll remove. There we are. Now let's see what it does. Much the same. Okay, so that cap we need to go back on. There is this too, by the way, so I'll go on that. I'll quietly whip that off as well. Again, just to prove a point. And now, again, let's still doing 2/3 of bugger off. Okay, we'll need to get into this and find out where that short circuit is, which is what we'll do now. Those parts I will change. I will put them back on, but it's obviously looks as though it's for the back. Capacitors on this nothing seems to have gone onto the board, and nothing seems to have exploded. The tops of them seem to be okay, so it doesn't mean they're okay, but for now I think that maybe they are. I noticed that that's not getting hot either, nor is that. It might be good or bad. So yeah, like I said, these things, usually with these things, take a quick look at them, but don't spend too long on them, because they can actually bleed your time very quickly. Because when you get into them, the problem, and you get into them, you know. So what I'll do now, whip it apart on the bench, and we'll see what we can find, if anything. By the way, with something like this, it's good to have 2 meters. One on the 8 put and one to look inside and check resistances and capacitances and voltages and that sort of thing. So 2 meters, very handy. That's a fluke. That's the one I normally use for most with the mercury. They're only 15 quid, by the way. They're well worth it. So have one of those if you can. They're brilliant. Right, anyway, let's go inside and let's have a look and see what we can find, if anything. Right, now I've got this thing well and truly apart. I mean, well and truly apart. With these, you just take them to bits, quite simply. The board is held down by screws and these things as well, which have to come out, and onto the base as well. So a whole lot comes apart like so to get the board in position to be worked on. What I did, I found that all these sort of power supplies, they always have a diode on the output of the transformer. They must do, otherwise it won't generate DC. Then goes to the capacitors, and then of course the output. But of course, I'll spawn it feeds back also. In this case, to feed the thing on the front, and also back to the primary to regulate it as power supplies do. So with this one now, the diode went out of circuit. The short circuit completely went away, completely disappeared, which I will show to you right now. Completely gone away. That first bit was capacitor charging up, but when it does, that is it. That no longer got a short circuit on it, not at all. But the diode on the other hand is dead short, I mean dead short. Again, I can demonstrate that for you here as well. That diode is dead short. No, it was. It was just new anyway. But well, there you are, dead short. 0 ohms. So that is a problem. Now with also with this sort of stuff, you don't know what this component is. Okay, it's 2 diodes, but is it a stroke key or what? So what I can do now, I've got the model number of the unit here. I've got a computer upstairs, so I'll go upstairs now and try and find out exactly what this component is, get one and put it in, and hopefully then this unit will come back to life. If it doesn't, I'm going to leave it, because I'm not going to this sort of thing any more than I have to, because they're fairly cheap. This one is just to show you. ACX power supplies in computers are the same, by the way, with cheaper capacitors. So in that case, capacitors do create a problem. But again, if it's not generating anything it should do, take the fuse out, check it. If it's faulty, how is it blown, if you can tell, and go inside and check all the things like this. Normally it's capacitors and things like this that fail, nothing else, things like this. Now I'm going to assume with this one that the power supply primary is okay, because there's no fuses blown or anything, so hopefully that's okay, but the secondary isn't, and this went after power cut, so maybe this was on the verge of failing. So we'll see what happens when I get replacement, and hopefully this power supply go back to Andy and it will be back in action. Right, now with this now is the case of much later, but what I did with it, I went online first of all with the make and model number, which is a Maas MPS-330-ii. I looked online for a circuit, which there wasn't anywhere online. I looked and looked and looked. I might have missed it, but that's rare. However, they did tell me it's similar to another circuit, the Linko. So I downloaded a copy of that, looked again a bit further, and I found that all these power supplies work with a diode on the output, which is a very fast diode. Which one power supplies do. This is because that's which is something like 100 kilohertz, and 4184007s simply isn't fast enough. So I got one, I've put it in, I've got it in state back and power it up, and so in a minute we'll see what happens with it. Switch on that, there you are. Can you see that okay? And hope you can, there you go. And in it now we'll see it works. I've also, by the way, with these, by the way, they've funded them as well, because Andy puts this thing on 24 hours a day, and the fan was disconnected inside. I wired it so the fan is on all the time. And now all there's to do now is to plug it in and see what voltage we get. This line will work, not work, or go bang. So let's see. 13.25 volts, 24 volts, 23, 22. And it's still at 22. Okay. Right, well I'll knock that off there very quickly. And that hasn't got too hot, but obviously the thing is now working as far as can be. It's a 13.5 volt supply, and it's also got regulator on the front as well, and a meter. They work as well, by the way, because I checked the plug. Push it again, and it goes. And the meter should go on. It does. There you are. Right. So the meter, although you can't see it, take it from me, the meter works as well. So this is now a working power supply and they can have back. By the way, for future reference with these, by the way, the transistor in question that I put in is available from Farnell. A U30 30-ii. That's a U30-ii. That's an ultra fast 30 amp diode in the TO247 package. Order code for it is 144013. And fan, I have about 400 of them in when I made this, so there's 28 there. CPC don't have them actually, but fan I'll do, so I ordered it straight from fan now, and it came in, as you can hear there and see there, the thing started to work. That was a load, by the way, as well, that was on, so everything seems to work okay. Also, I noticed that the class is discharged as well, so now it's just ready to go back to Andy and go under his bench again. So Andy, you take this back now, and it should work for you very well. As these power supplies go, it's very simple. AC mains comes in, which is DC, and the DC goes to the transistors here, on the input, and the transformer, and the switch, which acts as an oscillator as well. This is empowered by a smaller voltage to be started up. When it's up, when that's up okay, it goes to the transformer, through a diode which I just replaced, and to the output, but some goes back to feed it and hold the thing steady. That happens with all power supplies of this kind, whether it's the 3000-ii back in 1969, or one of these, or a computer power supply. Now, when these fail, how the fuse filled can tell you an awful lot. If it's still okay, then put your meter across the output and see what it measures as an ohm meter voltage, and that makes sure that transistor is not shorted. If it's not, then look for anything that's open circuit, or open circuit somewhere. If it's filled, as in just gently filled, try another one and see what happens. If it's filled rather more, then look at the board, but you do anyway if it's filled. Look for capacitors, the bridge on the input, anything like that. They're quite easy to fix in most cases if the parts are available, but if not, don't spend too long on them. This one, these are about 150 quid, these, so this is worth it, but power supplies of the computer kind generally aren't. But they're worth having to play with, and so until next time, keep fixing stuff, even power supplies, and I'll see you soon. Bye bye.